It's a red Goliath star. If you were to place it where the Sun is, it would extend to the orbit of Jupiter. It's tremendous, yet totally delicate, and is going to detonate. These effects are among the most important releases of radio energy in the entire universe, conveying more energy than a billion suns. Are you prepared for what will happen? This terrifying celestial creature, an epic red monster star and one of the closest stars to Earth, has recently undergone a striking dimming that has certainly drawn attention and sparked mixed opinions worldwide. This decline has prompted speculation among astronomers and the general public about its potential repercussions. Several experts believe the peculiar behavior could be a harbinger of a cataclysmic event, an explosive occurrence that takes place when a star exhausts its nuclear fuel and collapses under its own weight, causing a titanic explosion. Such an event raises concerns not only among established scientists but also among the general public, as it brings up questions about the potential impact on our planet. Betelgeuse, a prominent feature of the Orion constellation, is easily recognizable in the night sky due to its distinctive shape and bright stars. Also referred to as Alpha Orionis, it holds the title of the brightest and largest star in this majestic constellation. Continuous data collected by NASA's Hubble Space Telescope, along with observations from other observatories, have shown that Betelgeuse experienced a massive mass ejection in 2019. This event is rare for a star of its type and has piqued the interest of astronomers. While coronal mass ejections are a regular occurrence in our Sun, the unique event observed in Betelgeuse adds a fascinating dimension to how we understand stellar life cycles and the dynamics of massive stars. The distance to Betelgeuse remains a topic of discussion among astronomers. Some estimates suggest it is farther away, while others indicate it could be as close as 724 light-years from Earth. Accurately determining the distances of red giant stars like Betelgeuse is a complex challenge due to their immense distances and extraordinary properties. Betelgeuse stands out as one of the brightest stars visible in our night sky, shining many times brighter than the Sun. However, this incredible luminosity comes at a significant cost. Betelgeuse burns through its nuclear fuel at an accelerated rate, racing toward the inevitable end of its stellar life. Eventually, the star will exhaust its fuel supply, leading to a dramatic collapse under its own gravitational pull, potentially resulting in a supernova explosion. If current astrophysical theories hold true, this raises a critical question. Does Betelgeuse pose a risk to Earth? If such a massive explosion were to occur just a few hundred light-years from our planet, the consequences could be devastating. The impact of a supernova can release an extraordinary amount of light, potentially rivaling that of an entire galaxy. Interestingly, the last recorded supernova in our galaxy occurred in 1604. Humanity still lacks the ability to observe such an event locally. However, a remarkable supernova occurred in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While that event had massive effects, it posed no immediate threat to Earth, serving as a reminder of the scale and potential impact of such cosmic phenomena. The idea of a danger zone associated with a nearby supernova is intriguing and could have serious implications for life on Earth. If a supernova were to occur nearby, it's crucial to understand that, in the grand cosmic timeline, supernovae are relatively small events compared to gamma-ray bursts, which are far more powerful and represent a different kind of threat. Gamma-ray bursts can have devastating effects, capable of destroying biospheres and bombarding planets with harmful radiation. For instance, a specific type of galactic burst could lead to the destruction of a planet's ozone layer, leaving it vulnerable to the harsh radiation of the universe long after the event. This possibility was highlighted in a recent study that outlined new potential dangers associated with massive stars ending their lives in a spectacular fashion. When giant stars explode in a supernova, they can achieve some of the brightest luminosities known in the universe. In fact, the brightness of a single supernova can outshine the combined brightness of millions of stars. This raises the question, what would the consequences be if Betelgeuse were to undergo such an explosion? If a supernova were to occur, Betelgeuse would become the second brightest object in our sky, after the Sun remarkably. Despite the distance separating it from us, Betelgeuse, shining more brightly than a full moon, would become visible even during daylight hours. The sheer intensity of the explosion would result in a display so dazzling that shadows would be cast even in complete darkness. Such a spectacle would be both awe-inspiring and humbling, showcasing the raw power of cosmic events. While the visible light produced by a supernova is indeed significant, it is only part of the total energy released. The other forms of energy released during a supernova, such as gamma rays, neutrinos, and shock waves, can have far-reaching effects. If Betelgeuse were to undergo a supernova, these energy emissions could potentially impact Earth in various ways, depending on the star's distance. For instance, gamma rays from a nearby supernova could damage our planet's ozone layer, exposing life to harmful ultraviolet radiation. Additionally, the high-energy particles could disrupt satellite communications, electrical grids, and other technological systems. However, astronomers suggest that Betelgeuse is far enough away that such effects would likely be minimal for Earth, though they cannot be entirely dismissed. Interestingly, Betelgeuse's current behavior has become a subject of fascination in the field of astrophysics. The dimming observed in 2019 was initially believed to be a precursor to its explosion. However, further studies revealed that the dimming was likely caused by a massive cloud of ejected material partially obscuring the star's surface. This event underscores the complexity of predicting when a star will go supernova. Despite its unpredictability, Betelgeuse's eventual explosion will offer a once-in-a-lifetime opportunity for scientists to study a supernova in unprecedented detail. It will provide invaluable insights into stellar evolution, the life cycles of massive stars, and the processes that lead to the formation of neutron stars or black holes. Astronomers worldwide are monitoring Betelgeuse closely, using cutting-edge telescopes and instruments to capture data that may help unlock the mysteries of massive stars. The event will not only deepen our understanding of the universe but also remind us of the immense forces at play in the cosmos, forces that shape galaxies and forge the elements that make up our very existence. For now, Betelgeuse continues to shine brightly in the night sky, its fate still a mystery. Whether it explodes tomorrow or thousands of years from now, its story serves as a testament to the dynamic and ever-changing nature of the universe. As humanity gazes upward, we are reminded of our place in the cosmos and the interconnectedness of all things. The death of a star, while catastrophic, is also a moment of creation, spreading elements essential for life throughout space. In this way, Betelgeuse's inevitable supernova will not just mark an end but also a new beginning, a cosmic cycle that has repeated countless times across the universe. Delivered during such an occasion, albeit elevated degrees of noticeable light can cause brief visual deficiency, the more prominent concern lies in the high-energy radiation created close by the apparent light. This radiation frequently shows up as X-rays and gamma rays, which can have colossal effects. One of the main perils presented by this high-energy radiation is its capacity to catalyze the exhaustion of oxygen from the ozone layer, which safeguards our planet from harmful solar radiation. Without a sound ozone layer, life on Earth's surface would be exposed to extreme ultraviolet radiation from the sun, potentially leading to mass extinction events. In the fallout of a supernova, various dangers arise over time. In the first minutes following the blast, the intense radiation presents imminent dangers. However, over time, massive light beams and particles, pushed to near light speeds, begin to travel through the solar system. These powerful beams can break apart ozone layers and cover Earth's surface with harmful radiation, worsening the dangers presented by the initial blast. In addition, supernova beams carry a significant portion of the total energy released by the explosion, and their long-term effects can persist for years. There is evidence suggesting that such events might have impacted Earth in the past. For example, elevated levels of iron-60, a radioactive isotope created in supernovae, have been found in ocean floor sediment and lunar regolith. This finding suggests that Earth may have been affected by supernova ejecta in recent geological history, perhaps within the last few million years. Astronomers have already concluded that there are no nearby supernova candidates that pose an imminent danger to life on Earth, based on our current understanding of the risks associated with gamma rays and supernovae. However, ongoing research has revealed additional potential dangers associated with specific types of supernovae. These supernovae can release long-range lethal radiation that poses a greater threat to planets like our own. The mechanism behind this involves a star nearing the end of its life, surrounded by a massive disk of material. When the supernova occurs, a shock wave is created, striking this disk and causing it to become incredibly hot, thereby releasing a large amount of high-energy X-ray radiation that can travel vast distances through space. The brightest X-ray cosmic bursts have the potential to deplete a planet's ozone layer by as much as 50%, creating conditions that could trigger an extinction event within a range of about 150 light-years. Fortunately, no candidate X-ray supernovae have been identified in Earth's vicinity. However, this research has led to new insights into the concept of the habitable zone in space, the region within galaxies where conditions are favorable for life. The findings suggest that this habitable zone may be subject to additional constraints. Specifically, the outer regions of galaxies may not have sufficient star formation activity to create the elements necessary for the development of rocky planets. Meanwhile, the inner regions, where stars form and die at a faster rate, present their own dangers. Frequent supernovae in these regions can illuminate the surrounding space, increasing the risks for any potential life that could exist there. New research suggests that the inner boundary of the cosmic habitable zone is likely farther from the galactic center than previously thought, reshaping our understanding of where life might potentially thrive. So, what might a terrifying cosmic supernova look like from Earth? While Earth's biosphere will likely remain unaffected, the actual spectacle will be hard to ignore. According to scientists, Betelgeuse's supernova will continue to shine brightly for more than 90 days following its blast, reaching a brightness nearly equivalent to about half that of the Moon on some occasions, albeit much fainter than a full moon. Essentially, it will appear as a bright point in the sky, visible even during the day. Its striking brightness will captivate anyone who observes it, creating colored shadows at night. This celestial event will undoubtedly be a source of interest for everyone on Earth. As the enormous blast remains visible to the naked eye for months, its remnants will slowly fade. As researchers continue to study supernovae, they are uncovering more about the life cycle of massive stars and the processes that lead to their explosive endings. Understanding these vast phenomena is crucial for gaining insights into the evolution of our universe and the creation of elements. During a supernova, the light produced encompasses many heavy elements, such as gold, silver, and uranium, which are formed under the intense heat and pressure of the explosion. This process, known as nucleosynthesis, plays a key role in enriching the interstellar medium with the building blocks necessary for future star and planet formation. Interestingly, the remnants of a supernova, known as a supernova remnant, can transform into a stellar nursery, where new stars are born from the dust and gas ejected during the explosion. This cyclical process highlights the interconnectedness of cosmic events and demonstrates how the death of one star can lead to the birth of others. Scientists have identified several supernova remnants that are still forming new stars millions of years after the original explosion, showcasing the dynamic nature of the universe. Another fascinating aspect of studying supernovae is their role as cosmic distance markers. Astronomers use Type Ia supernovae, explosions from white dwarf stars that reach a peak brightness, as standard candles for measuring distances in the universe. These Type Ia supernovae have a consistent intrinsic brightness, allowing astronomers to measure their apparent brightness and calculate their distance from Earth. This method has been instrumental in mapping the scale of the universe and even led to the discovery of the accelerating expansion of the universe, attributed to dark energy. Supernovae not only play a crucial role in understanding cosmic distances but also in explaining the distribution of elements in the universe. The heavy elements produced during supernova explosions are scattered into the interstellar medium, where they become part of new stars, planets, and even life itself. Without supernovae, many of the elements essential for life such as carbon, oxygen, and iron would not exist. Furthermore, the energy released by supernovae can trigger star formation in nearby regions of a galaxy. The shock waves generated by these explosions compress gas clouds, igniting the birth of new stars. This dual role of destruction and creation underscores the profound impact supernovae have on the evolution of galaxies. In the larger context of cosmic evolution, supernovae are a vital part of the life cycle of stars. They signify the end of massive stars and mark the beginning of new cosmic processes that shape the universe. As astronomers continue to study supernovae and their remnants, they are uncovering more about the origins of the universe, the formation of elements, and the conditions necessary for life to emerge. Recent advancements in technology, such as powerful telescopes and sophisticated simulations, have enabled scientists to observe supernovae in greater detail than ever before. These tools allow them to study not only the explosions themselves but also the environments in which they occur. By doing so, researchers can gain insights into the factors that influence the behavior of supernovae and their impact on surrounding space. Supernovae also serve as natural laboratories for studying the laws of physics under extreme conditions. The immense heat, pressure, and radiation generated during these events provide a unique opportunity to test theories about nuclear reactions, gravity, and the behavior of matter. Despite the catastrophic nature of supernovae, they are essential to the balance and evolution of the universe. They highlight the interconnectedness of cosmic phenomena, where the death of a star can give rise to new stars, planets, and even life.